Graphing the inverse of a function given its graph. In order to start into this, we need some function call that function f of x. We also need its inverse, and typically we denote an inverse as the name of the function with a superscript of -1. Pay attention here, this superscript of -1 is not an exponent. We read this as f inverse of x. It's very different from f of x raised to the -1 power. All right, so we have a function, we have its inverse. Remember that the definition of an inverse is that if you take the composition of a function and its inverse, you get x, no matter which order you put the composition. Visually, one of the ways we can think about that is that a function f maps x values to y values. The inverse function, f inverse of x, tries to move the other way and take those y values and turn them into x values. So, if you have the graph of a function, and let's look at a fairly straightforward function here. Right, this is kind of a broken line graph. It starts over here at -2, -3, and then goes to 2, -1, and then 3, 2. I'm going to make a table of values for the key points on this graph. And I should label that this is the graph y equals f of x. To make the graph of the inverse, I'm going to take that same table and simply switch the x and y values. So instead of -2, -3, the first point will be -3, -2. And then, lost a negative there, sorry about that, -1, 2, and then 2, 3. If I sketch out another set of coordinate axes and I plot these 3 points, this time I get a curve that looks something a little bit more like that. And this is the graph of y equals f inverse of x. Before I move on from this, I want to show you one little trick. If I take my graph of my original function and I superimpose it on here with this graph, one thing that you will notice, and this will always work out this way, is that the graph of a function and the graph of its inverse always mirror each other across the line y equals x. Right? This is a symmetry between functions and their inverses, which will always be true. And that's a property that we will take advantage of a couple of times in this course. And moving onward to calculus, it's something that you will see there and take advantage of in that course as well.